So students, we are going to solve a few problems on the chapter polynomials, and you know the basic concept of solving quadratic polynomial. First let us have a look. Quadratic polynomial can always be expressed in form of ax square plus bx plus c. That is the first thing. Secondly, the sum of the roots, that means the zeros of a quadratic polynomial has got a relationship with its coefficient. So, if sum of the root is minus b by a, that means coefficient of x negative divided by coefficient of x square, then we have got product of the root c by a, that means constant term divided by coefficient of x square. And then if the roots are given for any quadratic polynomial, then we can again frame back the quadratic polynomial by just using this formula, x square minus alpha plus beta x plus alpha into beta. Taking the first question now, first you should collectively write down the data and the formula relations. So, question number 1, first the given polynomial is ax square minus 6x minus 8. Now, here what is given and what are the things we can retrieve given? First, we know that sum or the product, so the product of the root is given. Alpha into beta is c by a. So, I have already alpha into beta is equal to the constant term divided by the coefficient of x square, that is 8, that is a. Then we have got also alpha into beta is given, the product of the root is negative 4. So, we can equate equation 1 and equation 2. So, minus 8 by a is equal to negative 4. That means a will be equal to, this will cancel out. So, a will be equal to 8 by 4, that is 2. A will be equal to 2. So, that is the first solution. So, we always take down the data, isn't it? And then now let us move to the next one. Next question is given. So, first I write question number 2, I write down the polynomial. Now, here there will be a bracket for sure. So, it will be a square plus 4 x square plus 20x plus 4a, isn't it? This is given. So, if one zero of the quadratic polynomial is reciprocal of the other, so if I take one of the zeros as alpha, the other zero will be 1 by alpha. So, I start the solution. Let 1 0, that is the root, 0 be alpha. So, the other root or 0 is 1 by alpha, reciprocal, they are reciprocal. Now, we know that if I multiply these two, I will get 1. So, I will try to find out. So, product of the root will be, product of roots will be what? Let us see, product of the root will be alpha into 1 by alpha, that is equal to 1. This is equation 1. Then secondly, product of the root alpha into 1 by alpha will always also be equal to c by a, that is 4 by a divided by a square plus 4. So, this is equation 2. So, product of the root 4a divided by a square plus 4a, that is equal to 1. So, this goes that side, that is equal, just a second, a square plus 4. So, a square plus 4, this goes this side, then it becomes a square plus 4 is equal to 4a, a square minus 4a plus 4 is equal to 0. Factorizing this, we will get a minus 2 the whole square as 0. So, a is equal to 2. So, easily done. It is just very simple. Product of the root by the formula, product of the root by c by a, equate them and execute. Now, we go to the next one. So, I should need some board space. So, I will just rub this part off and I will rub this part off. So, now let us see. Now, I am going here. If alpha and beta are the roots of the polynomials. So, question number 3, first I will see the polynomial px is equal to x square minus 4x plus 3. So, alpha and beta are the roots and you have to find the value of alpha square plus beta square. So here what do we get? First try to see solution. We get alpha plus beta as minus b by a, isn't it? So alpha plus beta over here is minus 4 by 1, that will be 4. So this is equation 1, and alpha into beta is c by a. So alpha into beta will be equal to 3. So these two are the, these two are the sum of the roots and the product of the root, isn't it? Now have a look. Now we have to find out alpha square plus beta square. So we can write it, we have to find out alpha square plus beta square, but we know the value of alpha plus beta and alpha into beta. So is there any relation which equates, let us see, is there any equation which relates alpha plus beta, alpha into beta in this? Yes, there is one. We can write alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta, isn't it? So this becomes alpha square plus beta square is equal to alpha plus beta the whole square, that is 4 square 16 minus 2 alpha beta, 3 to the 6, that is 10. The value I am getting from here, 4 square is 16, so that is 10. See, if you examine carefully, you can also find out the roots and directly put in this formula. See, the root of this will be 3 and 1. You can get by splitting the middle term, you can factorize, get the root. The root will be 3 and 1. So 3 square is 9 plus 1 square is 1. 9 plus 1 is 10. So both the ways, why we don't prefer to take out the root, because sometimes the root can be in root itself, can be an irrational number. So then there will be a problem to factorize, and then there will be difficulty in finding out roots. Then we use these relations. See how I will use the other relation over here. We have to find out, in the second part, we have to find out what? Alpha square, beta square, alpha to the power, 4, beta square plus alpha to the power 2, beta to the power 4. I take alpha square, beta square common. So inside I have alpha square plus beta square. So alpha square plus beta square, so alpha into beta the whole square, and this can be written as alpha plus beta the whole square minus 2 alpha beta. This you have to remember. This relation I mean to say you have to remember, which I have used here. So alpha beta the whole square, alpha into beta is what? 3, 3 square is 9, alpha plus beta the whole square, that is 4 square 16 minus 2 alpha beta, that is 2 into 3 6. So 9 into 10, that is equal to 90. Okay. So now we go to the next sum, very important sum. Let us see how we can go to the next sum. See, we have been given, question number 4, we have been given this polynomial, isn't it? X square minus 7x plus 12, isn't it? This is the polynomial, this is equal to px. Now they are telling find a quadratic polynomial whose roots are alpha plus 2 and beta plus 2. But first we see what is alpha plus beta over here. It is minus b by a. So minus 7 by 1, that is alpha plus beta is equal to 7, and alpha into beta is equal to 12. So we keep this in our mind. Now roots of the required polynomial, roots of a required polynomial. Which polynomial is required? Whose roots are alpha plus 2 and beta plus 2. So we know the formula of any quadratic polynomial. What is that? X square minus sum of the roots plus product. So I am writing this again. Let me change the ink a little bit. So I am writing over here x square minus sum of the root alpha plus 2 plus beta plus 2 into x, then plus alpha plus 2 into beta plus 2. So this will be x square minus, let me arrange, alpha plus beta whose values we have 2 plus 2 is 4, x plus this will be alpha beta plus 2 alpha plus 2 beta, I will take it common, plus 4, isn't it? So x square minus, what is the alpha plus beta over here? What is alpha plus beta? 7. So 7 will be 7 plus 4, that is 11, plus here it will be alpha into beta. Alpha into beta will be how much? 12 plus 2 into alpha plus beta. Alpha plus beta is 7. 7 to the 14, 7 to the 14 plus 4. So how much is this? X square minus 11x plus 30. Now hold on. Now you see the root of this, if you can examine, it is 3 and 4. You can find out the root also sometimes, and the root of the required equation will become alpha plus 2, that is 3 plus 2 is 5 and 4 plus 2 is 6. You check on, I am telling go reverse. If you will find out the roots of this, it will be 6 and 5, and if you find out the roots of this, that will be 3 by 4. Just checking, it's, you know, the solution is done till here, was just checking it. Sometimes it is, if the equations are simpler, you can directly find out the roots, and then the roots of the required equation will be whatever roots you have found out. Now last question we touch, last question. See, the technique for all the question is the same. The technique for all the question is the same, children. All the question is the same. See, here they are giving you a polynomial x square minus k plus 6x plus 2 into 2k minus 1. This is what is your polynomial, and that they are telling has sum of its 0 equal to half the product. So let the roots be alpha and beta. Yeah, zeros be alpha and beta. Then according to question, alpha plus beta is equal to alpha beta by 2. Now what is alpha plus beta over here? Minus b by a, minus minus k plus 6. So it will be plus k plus 6, isn't it? Minus of here and minus of the formula, that is alpha plus beta is what? Minus b by a. So minus minus k plus 6 by 1, because nothing is there, so a is 1. And alpha into beta is what? 2 to the 4k c by a, 4k minus 2 by 1. Now I place these values in the equation above. Alpha plus beta is k plus 6. Alpha into beta is 4k minus 2. Now the k goes this side. So let us see, by 2, isn't it? By 2. 4 alpha plus beta is equal to alpha beta by 2. So this 2 is there. I am placing the values alpha plus beta k plus 6, and alpha into beta is 4k minus 2 by 2. So 2 over here. So this will be 2k plus 2, 6 is 12 is equal to 4k minus 2. So this is minus 2k is equal to minus 14. So k is equal to 14 by 2, that is 7. So all the quadratic equation, all of these quadratic equation have got a simple principle. Alpha plus beta is equal to minus b by a, alpha into beta is equal to c by a, and that those informations you gather, and then from the equation you get c by a and minus b by a, and just execute. Thank you.